This chapter talks about how you can organize and structure your automation task using the program block concept of the TIA portal. Most systems or production machines consist of multiple subsystems that can be separated from each other. For an engineer, a baking system may consist of the subsystems material feed, baking, and packaging unit. An automation programmer might further subdivide each of these subsystems into individual technical units, such as mixers, conveyors, and packaging. Even these can often be subdivided again into identifiable functional units that can be jointly used by multiple technical units, let's say multiple conveyor belts. This type of structuring forms the basis for easy solutions for complex tasks. And that is exactly where the TIA portal supports you with its programming and block concept. In principle, a single block can contain an entire program, command by command. This type of programming, however, has some distinctive drawbacks: too much complexity and therefore fault weaknesses, higher programming effort, and, more often than not, high memory requirements. In an effort to avoid all that, the TIA portal offers various block types for the encapsulation of your subtasks depending on requirements. The main program is generally stored in the cyclically called organization block OB main. OB main will then call up the corresponding unit, such as the technical unit of the first conveyor belt. Subtasks, like this one, are implemented as function blocks, FBs. A function block offers you flexible parameterization and comes with its own memory in the form of a so-called instance data block. Calling up FBs from within other FBs, interleaving, means that you can do call-ups as single or multi-instances. An FB called up as a multi-instance will store its data in the instance data block of the calling FB. This makes it easier to reuse that FB. In contrast, the program data accessible for all blocks are stored in global data blocks. A function, or FC, is used for the programming of frequently recurring subfunctions. These are generally much less complex. These functions have no memory and do not store any internal information beyond their own runtime. Once the program of the first conveyor belt has run its course, it will jump back to the return address of the block from where it was called up. One by one, all other components required for the system run will be called up in sequence. Identical system components, such as an identical conveyor belt, can now be processed by simply calling up the same block but with different parameters and individual instance DBs. How does that look in the TIA portal? Here we see a typical motor control function block that switches a motor off and on via buttons. All tags used by this FB are declared exclusively within this block interface. Its functionality is therefore fully encompassed. Let's say you want a delayed motor start. That means you will have to call up the command onDelay in the function block. You can choose between single instance and multi-instance for call-ups. A single instance command will receive its own instance data block to store the tags. A multi-instance command will have all tags stored in the calling FB's data block. For instance, the motor controller and the encapsulation will remain unchanged. You can also call up functions, FCs, in the block. Functions do not have instances, which means they have no memory. The function interface should therefore only be connected to tags from the block interface to maintain the encapsulation of the calling FB. The function block programming is now complete and can be called up any number of times. calls from within an OB are available only with single instances. That is why, with each call-up, an instance block is automatically created. And the block parameters are connected to the hardware inputs and outputs. Additionally, a release condition is queried by accessing the relevant tag from a global data block. The function block only physically exists once in the CPU memory, but can be called up any number of times in the program by an individual instance data block. The assignment of the interface alone selects a specific motor. The block program or its function remains unaffected. You can find an overview of all the blocks used in the tab called Structure. Here you can see the interleaving and dependencies, and you can jump directly to any particular usage location within the program. The block concept in the TIA portal offers a better overview of the entire system, reduced costs for testing based on modular programming. Functionalities created one time can be simply reused any number of times.